Everybody, Missy Check here again for our final day of notes for week 2 here. So before we get started on the 33.3 notes, I just wanted to bring your attention to this summary of information sheet. It's a really handy dandy helpful little sheet that's going to kind of overview lessons 33.1 and 33.2 so that we can kind of see some vocabulary, some examples of some definitions, things that are not polyhedra. You'll see all this down again, just some basic definition things, summary sheets. Just want to bring your attention to that. Now today's stuff is going to focus on this last little bit we haven't talked about yet, and that's our spheres. A little bit of talk about that, as well as just talking about some basic generating solids around a rotation, and that's what we're going to talk about here. So the three-dimensional shape that is represented by this real-life example here of a soccer ball is going to be, again, our spheres. And what you are going to notice is that spheres are going to be defined as the set of all points in space that are a given distance, aka your radius, from a given point, aka your center, all right, which would be located right here in that example. All right, the intersection of a plane through the center of a sphere is known as the great circle. So that's this biggest circle here all the way around through, again, the center. That's going to be our great circle. Now, example 1 down here asks us to think about, when you have a sphere, what would the size and shape of the cross sections be in our sphere, no matter where you're slicing them? Well, if we think about this, and we look here, we have a little investigation here on GeoGebra. Just Googled, cross sections of sphere to get this. Notice we have a sphere, and we are going to slice through this sphere. Okay, and notice that when we create that cross section, what we're going to see here is if we kind of spin it around, no matter which way we look at this, as we spin this thing around, that is creating for us a circle, okay? And that's going to hold true all the way around here. No matter where we move that cross section to, we're always going to create a sphere for a circle for our cross section of a sphere. So as we jump back to the notes here, then what we can write down is, what are the size and the shape of these cross sections? Well, the cross sections are all going, cross sections are similar circles. So again, they are similar. They're not going to be congruent, because depending on where you're going to slice, they're going to be different sizes. So again, the circles of varying sizes. Actually, the biggest circle is going to be the great circle that we talked about up above. The great circle is going to be your largest cross section in your sphere, and it has to go through the center. Now, switching gears a little bit here, we're going to start talking about solids of revolution. And a solid that is obtained by rotating a figure in space around an axis is going to be kind of our solids of revolution here. All right, the axis may not pass through that figure, so we're just rotating around it. So notice for this example here, we're going to rotate this particular triangle that you see right here. I'm going to draw that. When you have this particular triangle right here, what you do is, if you rotate it around this axis, so imagine you're kind of rotating it around, what you're going to notice is you're creating this figure over here, that cone shape. So again, it all goes back to creating that circular motion around. So what they're asking us to do in example 3 here then is kind of think about, what would that particular shape look like? So if we took this shape here, and again, we rotated it around and kind of followed the shape through, it's not perfection here, but what we're going to notice is what this is going to create for us down below is a sphere, right? We would have kind of that circular shape around here, and all the way around we'd have a sphere. Okay, so when you rotate around the semicircle, you get a sphere. Well, next example then, in example B, if we rotate this rectangle around, right, notice each piece of that around, what this is going to create for us is a cylinder. When you rotate the rectangle around, you get a cylinder. Last but not least, this one's a little tricky. As we rotate this one around, rotate this one around, rotate this one around, and kind of connect our figures. All right, notice what we get here. It's a little bit different shape. In fact, it's two shapes. And what we would call these, they kind of look like the beginning pieces of a cone. Like imagine I took here, I added on a cone top here. Okay. Pen to work. This kind of looks like a cone, right? The beginning pieces of that at least. So what we would call this is officially the two, this fancy word here, frusтрums of a cone. And that basically all that means is the cone without the vertex. But sometimes you're going to get multiple solids created, and that's what they're trying to get you at with example C. Okay. So in closure, kind of a short lesson here today. All right, some things you could do, you can create your own solid of rotation. So look at the example here. Take a straw and cut out your own picture here and be creative and post it on our Google Classroom. Oops, it's supposed to say Google Classroom. And rotate that around and show what kind of shapes you're creating based on the solids that you are rotating. Okay, so a nice way to do that, again, take a straw and do that. And the last thing, go outside if you can. Dribble something or throw something or kick something that is a spherical shape. Okay, have a good day, guys.